Welcome back. Today we're going to be talking about landing, AutoLand in iNAV 8.0.0. And to get it kicked right off, GitHub has a very good little explanation of it. And it's at that link, which is posted in this video. Just look in the information for the video. And you've got to read through this if you haven't done it before to get a general idea of how the whole thing works. There are quite a few settings. I'll go through them right now. They have a nice little diagram right here which explains how it works. The plane is coming in on a return to home, let's say, for example, and you've got automatic landing on return to home. It will circle around the home position. You must have a home position set. And then it will calculate the wind and determine which way it's going to land. And then when it finally does, it'll go on to what's called AutoLand sequence 1, which is doing the calculations for where it's going to land and how. 2 is when it flies downwind, like so. Then it'll fly a base leg across the wind, which is usually about half the length of your landing distance that you've set, and we'll see that in a little bit here. And then it goes on to the final, well, not the final, but the approach leg, which is number 4 in the sequence. And then it goes into 5, which is the glide. And if you have a LiDAR detector for height above the ground in the plane, it will go into the flare mode and do a nice little landing. So go through this, read it. They show a little diagram here on the vertical axis of how the whole thing works. And like I said, that is in my my video description. Now here's the return values of the landing states. 0, it's not active yet, it's idle. 1 is loiter, that's when it comes close to the home position and loiters around the home position, trying to figure out how it's going to land. 2 is the downwind leg, 3 is the base leg across the wind, 4 is final approach, 5 is the glide, and 6 is the flare. Okay, well, let's get right into the settings. So connect to the flight controller. And the first section that is really important is in the config. We'll go to config right away. I assume you've got your plane all set up and it's flying nice. It flies by itself. It'll return to home okay. It'll loiter properly around the home position, etc. So in the config, you must have the black box thing on if you want to get the logs. If you want to keep the logs so you can display them on a display device like Google Earth, you must have the black box flight data recorder on, this one right here. Okay, that one must be on. And then in addition to that, sorry, for black box, go down to black box here. You must be sure that this is on, the data recorder, that you've got an SD card on board the flight controller, and it's been formatted to FAT32. And this is pretty much all set up automatically. You can change some black box fields here if you want to. You can read about the black box also in GitHub. There's a real good section on how it works. And you can download the black box. It's a little app. It's actually like an exe, and you drag your log files that you take off of the SD card, and you plop them onto that exe, and it'll create a GPX file, which is then usable in Google Earth to display the path of the plane. You can see how it flew. It's really cool. And then it gives you the card. This must be showing here. Card ready must show before you are able to save on that SD card. Okay, so configuration, that's about it. Let's go to failsafe. In failsafe, I've got return to home set. That's the way I like to do it. That has to be on for sure. And then in advanced tuning, if we go down here, there's quite a few parameters in here. In the fixed wing nav settings, the ones to be careful of, and that are probably set properly if your plane is flying right are these three right here. I would put allow manual throttle increase on in case there were any problems, like something happened and you wanted to give a little bit more throttle to not hit something or to regain altitude. I always have that one on. The pitch to throttle ratio, very important, probably the most important part of this for the landing sequence, because that tells the plane how it can increase or decrease the throttle depending on the down rate, the speed forward, and how far it is off the ground. I've got this set to 10. Throttle smoothing, that's not really particular to the landing sequence. These are all settings that are typically set before. Okay, so if we go down here a little farther, I changed this, sorry, bank angle. I changed it to 45 degrees so that the plane could bank a little steeper and get around the turns a little quicker. And you'll see my flight is a little bit wavy sometimes. I have to still deal with the speed versus the bank angle versus the radius that we're going to see in a few seconds here around each waypoint. Okay, the max alt hold climb rate, max nav cruise rate, that's loiter radius. This is the one here. See, I've got it set to 98 feet. I fly on these tests. It's a pretty slow flying, high wing plane, very friendly to turns. And it does take a little longer, let's say, than a fast moving plane. It's not as quick to respond, but I could put the radius down a little tighter than this, I'm pretty sure, and get it to crawl around pretty good. And my waviness of, tipping one wing to the other would probably disappear. I've got my loiter direction set to left hand. I'm an old-fashioned flyer. I love to land the plane coming in from the right to the left. So if you're looking out your right eye, the plane is coming in that side of you and landing that way. Flying in the other way, I can do it, but I have to think a lot more, and I'm a little bit lazy at thinking at my age, so I prefer to have it in the left direction. Okay, so that's about it there for that section. Now, in the fixed wing landing settings, you see I've got my approach length. That's the number 2, what we call it in the landing sequence. 1 is where it circles around the auto point, the home point, and tries to figure out how it's going to do it. And then 2 is the, this is number 4, the approach. That's just before it lands. It's the final straight down to the earth, final approach. This is the setting that you have to be careful of. Don't make it too short. But you can play with this if you're using a device like X-Plane. You can kind of play with it before crashing your plane. Just run it through X-Plane, do a little test, see how what X-Plane thinks of it. And if it works in X-Plane, there are very good chances that it's going to work in the real scenario outside on a landing, on a real landing. Okay. Modifier for pitch to throttle control or final approach, I've got that set to 200%. That's the amount that it can modify the throttle response in order to not crash into the ground and to not overshoot your landing point by too much. The initial altitude of the glide phase, I've got it set to 6.56 feet, which is pretty low. Some people like it 10, some people like it 15. I started at 15, it worked pretty good. I've set it down to 6.6, the 6.56, because I set it in centimeters, of course. So it's getting kind of a decimal point configuration there. Initial altitude of the flare phase, that's just before it really cuts the throttle right down and it flares, the nose going up to try to flare and come in and land on the main gear. Pitch value for glide phase, I didn't even touch that yet. Pitch value for flare phase, I've got it set to 8 degrees. Now you've got info for these out here too if you want to read them. There's a little bit of information available here. Maximum tailwind, that's when it's kind of figuring out where it's going to land. If the tailwind is higher than this value you've set here, it will not try to land in a direction with the wind. In other words, there's two ways you can fix the landing. You can say, I want it absolutely to come in from only one direction only, and never 180 degrees reverse to that direction. And we'll see that when we get into the schematic drawings on the mission planner. But I like to set it for one fixed value. And if the tailwind is higher than this value right here, it will think about it again. Okay, that's the landing. Now the return to home, right down here, you see I've got it set to at least. You can set it to at least, or current, extra, fixed, or max. Now I like at least because that gives me some play above that. And I set the return to home altitude at 164 because I do a lot of flying over forested places where the trees are quite high. Return to home altitude, I set it to 0 feet because the home altitude, typically that's where it's going to land at, or the landing point that we're going to see in Mission Planner in a few seconds. I put that to 0 feet. I could be wrong, but I'm very new at this as well. But I've had many, many successful simulated flights with AutoLand, so I think I'm getting to learn pretty good. Climb before return to home, I have that always on because if you did have to, say you were going down and you noticed the plane was not where you wanted it to be because of wind or whatever, and it was going to hit a tower or something, so you initiated a return to home suddenly. Well, if it flew flat at that low altitude that it was at, it would probably hit the tower. But if you say climb to the specific altitude, this one right here, before returning to home, then it will probably climb out of danger and return to home. Climb first stage method, at least. Okay, climb first stage altitude. I don't use that. I don't use stages in the altitude myself. Linear descent start distance. I haven't bothered with that too much. Climb regardless of position sensor. No, I don't want that. Override the return to home and with rolls. No, I don't want that. If you want to override a return to home that's been initiated and the climb, you can hit the roll pitch stick if this is on, and it will come out of that mode. Return to home trackback mode, I have it off. I don't use that. I don't use that either. Return to home mode. Now that's return to home. That's what I want. I don't want it off. This should be on return to home because I'm doing an AutoLand. I like it that way. It works better, it seems. Safe home max distance, 1,000 feet. That's when you turn your flight controller on and you get your first GPS location. If you're more than 1,000 feet away, in my setting, it will complain and it won't start the arming process for you. Okay, safe home max distance, land after return to home. This has to be on always. I've got it on always. You can put it on fail-safe if you want, and you can fail-safe it to make it land, but I prefer always for these tests until I get to know all the rest of the parameters. Minimum return to home distance, 16.40. That's something you would set before. Return to home abort, that's something before. Fail-safe mission delay, okay. That's something that would have been set before and is not AutoLand specific that I know of. All right, so let's return to home. Now in the waypoint nav settings, here's the radius I was talking about that I could possibly increase a little bit. I've got it pretty tight. I've got it at 26 feet. Who knows? I might be able to do 10 feet. That test I'm doing is with an E-Flight Apprentice. It's a pretty friendly little plane, so it doesn't fly too fast. Waypoint safe distance, 4,921 feet. You can set that to whatever you like. That's basically the maximum distance between the home point and the first waypoint. Load waypoints on boot. Yeah, that's kind of nice to have. Load the waypoints from the flight controller that you have in your memory at that time. And we're going to see that in a few seconds here. Enforce altitude at waypoint. I usually have it around 20 feet. I find it works pretty good. Waypoint tracking accuracy, I've got set to 6. Waypoint tracking angle, I've got it set to 60 degrees. The waypoint turn smoothing on cut. I like a nice smooth turn. You can put it on or off if you want. I like to have the on cut because then it won't bypass the waypoint, or it won't wait until it gets right up to the specified distance that you've set. It will do kind of a smooth turn. It'll do a cut like through the corner of the turn. Restart waypoint mission. Okay, that is on a switch, and I really don't use that at all. Okay, let me see. Automatic landing settings. That's about it. The craft was okay. These are all set. These are the settings I had set before. You may want to change these for the automatic landings. I had these set for fail-safe, I think it was, and you can look at these. You can set them to the same point I have them, or you can play with them. They give a description of each here. And that's about it for the advanced tuning. So on the GPS, you must have a GPS set. I find that I get much better landings, and there's 2 other reasons why I like to have a GPS set. If you notice on your screen, if you ever posted the time on your OSD, you will not get the time unless you've got a GPS that's operational and it's got a fix. The other thing I didn't like is my log files didn't get date stamped properly, because that is taken from the GPS time clock as well, it looks like. Because when I didn't have my GPS on, my log files were getting some weird date like 2015, and we're now 2025. It was only 10 years off, but it's enough to make you want to drive you to drink, I think. Okay. So GPS, you got to set this to on. You set the serial port. It's GPS. You probably all got this already set up, the whole thing. I won't go into how to set up a GPS. That's not what this session is about. However, it should show that it's got a fix here before you start any flights, that's for sure. And especially when you do an X-plane test, I don't think it's going to do the AutoLand properly if the GPS isn't working. At least that's to my experience. Okay, so mission control. Here's where it gets interesting. You'll see I've got my home set here. This is my safe home. I've got several rooms. This is number 3. And this one just so happens to be at an airport in New Brunswick. It's Miramichi Airport, used to be our CAF base. And you see the latitude and longitude are here. And we'll see later how you can position the plane right here. I've got a little video just after this section we're talking in. It's in the same video, but you'll see how to get a waypoint so you can put your plane on that runway using Google Maps. And I've got my approach altitude at 60 meters, about 180, 190 feet. My landing altitude I've got set to 3 meters. The elevation is not correct until I do a MP elevation. You see it's set to 9 meters right now. I know that's 30 some meters. And and then when you set sea level reference here, you'll see that 9 meters change. If you set this, it goes to 29 meters now, which makes a lot more sense. I usually don't run it with that on anyway. I like my above the ground references. Okay, so that's the, and of course I've got my heading on the runway. I've told it I want to head in this direction. And this here means that it's only in that direction. You see, if I turn this off, what it does is it plans a secondary route. So if the wind is going in this direction, it won't try to land with the wind. The plane's supposed to land into the wind. It'll go in this direction. But when you click this little slider right here, it will take that one off, and you're telling it, I want to land only in that direction. Now, some people wrongly in some videos say you got to put a minus before this. It won't work. If you try to put a minus there and you do that, it goes to 360. It doesn't like that. So what they're referring to is in the mission file that's created, this little switch that you set here causes that 78 in the mission file to show as minus 78, which is telling the flight controller land only in that direction. Okay, and I've set that off. You see, I didn't do that right. I didn't type in the right number again, so that should be like 76, I think, something like that. It's even less than 72. That's pretty close. Okay, once you've got all these settings for your safe home setup, then you've got to load your mission file that you've created by putting waypoints on the screen, like this right here. And you'll get these waypoints all set up, and then to look at those, you hit, and to check your landing parameters, you click on the landing icon. If you don't have it, just put a waypoint on there, and when you go edit the waypoint, make sure the type here is not a waypoint, but it's LAND, land. That's the final point where the plane should touch down, or should head at least in that direction, to be close to that point. And on that land waypoint, you see I've got it set to 60 meters, altitude, longitude. The approach, fixed wing settings, 60 meters, the altitude. The landing altitude is set, I've got it set to 5 meters. I've gone down as far as 2 meters. It worked pretty good. Approach direction, I have it to left. And I don't have any heading direction here at all. My only heading direction that I have is in, as I said earlier, the safe home 3. Okay, so that's about it with the mission control. Don't forget, when you finish all of this, to save your mission to the flight controller and also to your EEPROM mission. And the same thing for the safe home, this little icon right here. Be sure to save that to the EEPROM. Okay, let's take a look now at the OSD. The OSD, I've got something on there which tells me something very important when I'm looking through the goggles. I'm knowing what land state is happening right now. You see I put the 2 words here, land state, and in the middle I've got the land state number. And I set that up in those very nice custom OSD elements that they were good enough, the developers, to give us in the last year. I've got a global variable 4 that I set in programming, and I'll show you that in a second. I'm taking that global variable 4 and I'm placing it right here, and it contains the value of the land state number, whether it's 0, 1, 2, 3, 4, 5, or 6. I've got a text there for land. I've got a text here for state, and I put those here and here. And I've also got the throttle state on the screen. If I go to the right one here, you'll see it. I've got that in screen number 2. I've got the throttle and the value right here. So I created another little OSD element right here for global variable 6. I placed the value of global variable 6 for that one. And I've got a little text name for it called throttle. Okay, so that's it for OSD settings. What do we do now? Black box, I covered that. So that's pretty much it. Let's go into have a look at how we're going to test this thing and see if it really works. So the airport we're going to be testing it at is in New Brunswick. It's the Miramichi Airport, this one right here. Let's zoom in and have a look at what that looks like. It's an ex-RCAF Air Base Training Center that was moved politically to Quebec and other places. Killed the economy literally in Chatham. But anyway, we're going to be landing on this runway right here. So let's test that landing procedure. Before we run the flight simulator, explain we need a point on the runway where we're going to take off. Like we have to position the plane on the runway at some place. One good way to do it is go into Google Maps, type in the name of your area where you're going to fly, go into Google Maps, and then just zoom in on the airport or the position where you're going to take off from. And I'll show you how to copy the latitude, longitude quite easily. So there's the runway we're going to be landing on, taking off on. Let's just position ourselves, let's say about here. You right click on the dot you just created by left clicking. You see the latitude, longitude, click on that, and it would say copy to clipboard. That's all there is to it. Nice, neat little tool you can use to see the track of your plane after you did the flight on the world map that Google has, Google Earth. I use Google Earth Pro. What we do now is we can connect with the flight controller to the SD card in the flight controller. Go to the CLI, type in MSC for Mass Storage Connect. That will reboot and furnish a D drive that we can go and access the log file on from the flight controller. There it is right there. We just copy that. I'm going to take that and put it where I store my log files, right here. Now what we do is we drag that file after it's completed onto the program for black box decode. Just take that text file right there, that one right there we just copied. Just put it on the black box decode exe. That creates a little bunch of files, 3 more files. One is the GPX. That's the one we need for Google Earth. So let's go and fire up Google Earth. Let me see, right here. And we'll drag that GPX file onto Google Earth. Right when you drag the file onto Google Earth, like so, the GPX, move that over there, okay that. You need these two checked, top and the bottom one, and it will draw the trace of your flight. And you can zoom in on that. You can check the different locations. You can even, well, it depends how fancy you want to get with Google Earth, but you can tilt things and make them look. You can even change the orientation so that you see the orientation from a different view. Gives you a pretty good idea of what the flight did. Excellent. We're going to use Google Earth this time. We'll plug in with our XP to Earth. You turn tracking on. You can turn pilot view on if you know how to use X-Plane a little better than I do. Go down to Link, iNAV. You want to go to Map, and then you teleport to Location. That means you've got your location, latitude, longitude, in the clipboard. It will place the plane at that exact place on the runway. Then you go down again to Map, and this time, after you've got the flight controller connected, you will load your map waypoints from your flight controller. And then you're ready to go. So when your XP to Earth is connected, you just say connect Earth, everything is ready to go. Window right here. So we'll just put that over here for now. You can change the view here. You can go view full screen. Change it back again, take the full screen off. You can go to different views. You can go to, let me see, view size 1920 by 1000. More of a high def look view. I like it view size of about, let's say, PAL size up here, so you can move it around and you can still see on Google Earth what Google Earth sees of this Miramichi Airport. And then we'll arm the vehicle and push up on the throttle and move forward. I'll have the sound set off because it's annoying to make a video and hear that sound in the background. Okay, we're off the field. We'll go to waypoint.
Waypoint mission.
Got 4 waypoints set. And you can see now you can move this window around, so if it's hiding your on-screen graphics, your OSD, you can just move it to where you like. In this case, we're looking at the land state here. So I'll cut this flight a little short. We'll go right to
Return to home.
RTH. so we can have a look at the landing states as I go through it. So the wind is 0.78 miles per hour. When it adjusts for its landing routine, in other words, what track it's going to follow, downwind, crosswind, and approach, I've got it set to fix. So I'm coming in at, I think it's 78 degrees or 76 degrees roughly. And I set it to don't use the option if the wind is the wrong direction. I want to come in always from the same direction. Make it a little more predictable for this video as well, so I don't look like an ass, you know what I mean? Okay, so we're now in state 2, so we're going downwind. We're going along this runway right here. There it is right there, okay? The Google Earth view is a little smaller. We can make this full view to take a look at it better, full screen. Okay. All right. Take the full screen off. We're in landing state 4. We're coming down the runway. On the approach, we're in state 4 on the approach. We want to state 5 for the glide, and we're down. So that's how you use Google Earth, and you can switch this off at any time just by killing it like that. Okay.